So let's go back to our idea of using a grounding-based chatbot. So a chatbot that can answer questions using a knowledge base. And you know that you can query the knowledge base with Sparkle. So the question is, how can we come from a natural language question to an answer that we retrieved from the knowledge base? In general, there is no single solution for doing this. This is quite a complex problem. In some areas, this is an open research question. In general, if you can limit it to a specific subtype of questions, to a specific domain, to a limited set of questions, the easier it becomes to implement it. If you want the bot to be able to handle pretty much anything, any domain, any topic, any type of question, then it becomes more complex. So here is a possible workflow. The full description you can read in this publication here. So you come with a natural language question, you go through this natural language processing pipeline that we talked about. You do part of speech tagging. Possibly if you have a specific domain, like biology or technology or business, you can enhance this with domain-dependent information. You feed this into a parser. You get the semantic representation of the sentence. You know what is subject, object, and different relationships. And then you can match this against Sparkle query templates. So I talked earlier about different question types, like question about time, about money, about location. And then we can match the queries against these templates. So the actual data comes from a Sparkle endpoint, which has possibly your own company or domain project-specific information. Like in the course project, you feed it with data about university courses, but it can also access information from the linked open data cloud. So now that we've done this, we can use templates with slots for different information. For example, a slot for an entity, for a person, for a money, for a percentage. We have possibly more than one query from these different templates. We get different matches because of ambiguity and different representations. So we can have not just one possible candidate, but multiple candidates. And we can rank them. Again, you could use machine learning, or you could actually try to run a few queries and see which one gives you a result. And then finally select one of them and format the result as an output. So for generating the query, one input is the syntactic structure of the sentence, one possible input. So again, there is no single correct recipe. There are lots of different things people experimented with, starting from simple patterns that you apply to the input to more and more sophisticated, deeper analysis. But again, when you apply standard NLP, now you have an input sentence like, when did Princess Diana die? And you run it through the syntactic analysis. This is basically a parse tree, not just nicely formatted. You see now the different constituents, noun phrases, verb phrases, and the dependency relation between them. And then you can, again, do a match of a syntactic pattern into a question type. This is, again, you have these different type of questions, and these questions match into different categories depending on the structure you find here. So it's, again, machine learning based on the syntactic structure. And then once you have identified this, again, you have possible templates that you fill in. And again, you can have multiple templates. Like for the question, how many children did Benjamin Franklin have? You could generate a question where you ask for it directly, or you try to compute it yourself using a count. And then you can, for each pattern, you often have multiple candidates that you can run. For example, select the best matching one by just running the query and looking which one gives you a result. Similar here, more complex question. Who is the Formula One race driver with the most races? So again, that's quite complicated because you need a somewhat more sophisticated query. So you do the syntactic analysis on the sentence, you extract the information that is relevant, and you combine them with a Sparkle query pattern. And then you can run this query and get the answer for the query here. So once you've done this and you find an answer, you again want to evaluate your system. Now, this is another AI system, a question answering system, and you want to know how good is it. And if you have a corpus, you can do the same thing that we have done before. You can do a performance evaluation using metrics like precision, recall, F1 measure. We've done this previously for the recommender systems. We talked about it in the standard context of machine learning. Specifically here for queries, you would define recall as the number of correct system answers for the query over the number of benchmark answers for this query. And the precision is the number of correct system answers for the query over the number of system answers for the query. And then F1 score is computed just like before. Like for so many tasks in AI, there are data sets that are existing. And one very nice one is this Stanford question answering dataset squad. So have a look at the link here. This one, that you can browse the data set and you can see some text that you can use for learning. And then you have the questions with the ground truth answers. So for example, which type of climate may have been allowed the rainforest to spread across the continent? And yeah, you can see the answer is the wetter climate. So you can see a number of ground truth answers, and this way the question answering system can get a match with any of those ground truth answers. Now, there are slightly different ways of answering the same question, and multiple can be correct. So again, have a look so that you get an idea on an existing data set and what systems can do for answering questions like this. And then for trying again, based on the earlier exercise with the question classification from natural language, we're going to do a very simplistic approach to try to match it with a question category that you could then use for filling it into a Spark query. So it's the task number 6 on the worksheet. And then I'll see you again in the next lecture part.